Hi everyone, welcome back. Here's video number 2 on area under the curve. I decided to make one that's similar to the first, but it's tricky because it's got a square root. Let's have a look at what we're calculating. Here's the graph for y equals square root of x. How do I know? By the way, if I put in 0 for x, square root of 0 is 0. So that point over here is 0, 0, which we talk about as the origin. If I put 1 into there, so if I pick x as 1, square root of 1 is 1. So that's 1, 1 there. And if I put 4 in there, I'm going to jump to 4. I could use 2 or 3, but I just call them yucky. They're not as nice to use. Square root of 4 is nicer because the square root of 4 is 2. So that point up there is 4, 2. Now what we're trying to do is calculate the red area. The area under that curve between 1 and 4. Now let's have a look what happens with it. The system is, you put a summation sign, which is not convinced that it's totally that, but I'm fairly convinced. We're going to start at 1, we're going to go to 4. 1 to 4 of the square root of x dx. Now, we cannot integrate something that's in that form. The only rule we know for integration with polynomials or simple functions is that you can increase the power by 1 and divide by the power. So here's the big thing I nag about over and over again, and I see people mess it up, talk about rearrange. Well, I've said that so many thousands of times. Let's have a look at what we've got. The integral from 1 to 4 of x to the half. So if you want to have a look at videos, I've got plenty of videos on using algebra and index laws. So square root of x, most of you be okay, you could just write that as x to the half. All we've done is rearrange. I've seen people then substituting 4 and substituting 1 and mess up the question. Now we can do the question. Now it's ready to be done. So let's have a look what happens. So we're going to add 1 to the half. Now most of you should be okay with a half plus 1. Now you could write it as 1 1/2. Most people in math, it's like an unwritten law in the world, write it as 3 over 2. So I've got x to the 3 over 2. Now I divide by what? Now what's the problem here? What's the complications? If you get this in your exam, you're going to have these sorts of numbers that can muck you up and you have no calculator. So we've got x, add 1 to the half, becomes 3 on 2. I do often talk about this, ready? Looking at this and I go add 1. And these are what I call the i's. We're integrating, and when we're integrating, we increase the power. So we are integrating, we increase the power by 1, you've got 3 on 2. Then the last bit of the rule, you've got to divide by the powers. That's 3 on 2. And then I can put plus a constant, and then I can put the square brackets in. We're starting at 1 and we're going to 4. Now this is where it gets interesting. Why do you like it, your fractions? So we've got x to the 3 on 2, on 3 on 2. Now, remember that's a divide. Now there's so many ways that people talk about. Most people will talk about invert and multiply in my experience, but I found other people have other words for it and I can't remember. Something about flip. Write it and flip, I think. So you write the numerator first, then you multiply, you turn the divide into a multiply, and you turn the denominator upside down. So this is what we call invert. See, that's been inverted. So that's inverted. And we invert and multiply. So what we've got here is actually, so now we've got, this is a numerator, that's a numerator, that's a denominator. So we've got 2x to the 3 on 2 on 3. And this is where people really come unstuck, is these calculations here. Now I'm going to run out of the room. I think I'll go back up there in a moment. And we're going to substitute 1 and we're going to substitute 4. You watch how much people don't understand the rules that are behind this. So what does this mean? We're going to substitute 1 and we're going to substitute 4. People substitute the bigger number first, so let's substitute 4 and watch these calculations. If we get rid of those i's, watch the calculations up here. We're going to have 2 times by 4 to the power of 3 on 2, and that's where people really come unstuck. So it's not about the integration, it's not about the area under the curve, it's the calculations in here. So 2 times 4 to the power of 3 on 2 over 3 plus c. We're going to subtract, and I could put brackets around all of that. What's what we do now? It's 2 times 1. So this is substitution. 1 to the power of 3 on 2. You can see why people come unstuck on the plus 3 plus c. And there's our whole calculation that we have to figure out. Let's have a look at what that is. If you want to watch, I do have videos on fractional indices. So if you go to my index laws and you go through, you'll find them as 3 on 2. I even got on my 1 minute math if you want to have a look at it as well. Now I'm going to do this a short way. I'm not going to go to great length. You need to go to other videos to watch it. What we're looking at here, we know we've got a 2. We've got the square root of 4. Now let's have a look at this. So that little bit there means the square root. Now is there any doubt in your mind what the square root of 4 is? Hopefully not. The square root of 4 is 2, but it's still got this other 3 up there, and I'm just going to leave it there. A lot of you can do it in one go, but for the moment I'm just going to leave it there. So, square root of 4, and then we've got another 3 on top. So there it is on top, on 3. Now the c's are going to cancel each other out, so I'm not going to bother to write those. Let's have a look at this one now. Minus 2. Now it's the square root of 1, and the square root of 1 is 1, and 1 cubed 1, so we've just got 2 times 1. And the calculation turns out to be quite nice, especially when you're using numbers like 1 and 4, or maybe 9 and 16. Let's have a look what we got. 2 cubed is 8 by 2, so that's 16 on 3, and that's 2/3. So we end up with subtracting the tops, 14 on 3. And if you wanted to, you can go how many 3's go to 14, and it's 4, and there's 2/3 left over. And we talk about unit squared. Now before I forget, we talk about in maths an area under a curve. Now if you look at that curve, you could keep going down and down and down. So it's become acceptable, the whole world talks about, or most of the world that I know of, talks about area under the curve. So it means from the curve all the way to the x-axis. And you can see what's going to come next. What happens when we go below the x-axis? What happens if we have a part of the curve above the x-axis and a part of the curve below? So I'll see how I go making up these videos and see if they're helpful. Well, I hope you found it helpful. Thanks for watching. Bye for now.